Section 1, Chapter 1, Lesson 2. So we're going right to arithmetic. So this one's just strictly RF9. The reason I'm saying those outcomes is that's what you're going to see in your grade book. It's going to be the RF9 column for relations and functions. And first, focus on arithmetic sequence patterns. So if you remember from last class, the biggest thing we noticed with arithmetic sequence patterns is their graphs displayed what? Well, the linear relation. And they were linear because they're constant growth. They had the same growth the whole time, and so they're consistently growing. So we use that information to our advantage to help us figure out the patterns and to solve and define different things in relation to the general term of the sequence. Okay, so let's kind of go through that, but that's kind of where we're going. So arithmetic sequence is a sequence in which each term is formed from the preceding term by adding a constant, positive or negative. So add a -3 or a +3, for example. So looking at this one here, 7, 10, 13, 16. So each term determined by adding 3 to the previous. Okay. And we're going to go ahead and make the point about a common difference. Common difference is that constant growth we talked about. You can get that by subtracting previous terms. 10 minus 7 is 3. 13 minus 10 is 3. 16 minus 13 is 3. That's showing you the consistent growth, the common difference. Okay, those should always match if it's arithmetic. Okay. So it says notice the common difference between the two. The common difference in this example is the 3 again. So real quick, after you finish writing that, I want you to look at the back page of your book, the actual cover. So the very back cover, it's your formula sheet. Okay, so there's your Math 20 formula sheet. That's the formula sheet you'll get for every test that you need it. And this chapter is about half the formula sheet. That whole top half comes from this chapter. Sequence series just is basically a lot of formulas and how to use the formulas, okay? So just that's where you'll find those. So those things there you don't have to memorize. Okay, those are given to you. Okay, so for basic just understanding, the common difference comes from subtracting previous terms. And so this is just a quick common difference formula. You don't really need a formula. All this means is term minus the previous term. N minus 1 means previous. So if it's a 6, that's a 5, right? 6 minus 1 is 5. So constantly subtracting the previous term. So the common difference in this one, now the change, it switched the order. So this is not 3, this is -3. And you can find this by going 13 minus 16, or 10 minus 13, or 7 minus 10. All those are going to give you -3. Okay, so your common difference for that one's a -3. Okay. All right, so for this next set here, for example 2, we're going to determine which type of sequence it is, and then we're going to find the common difference if it has one. So if it's arithmetic, then we'll find it. Okay, so like for example, we're just going to say, okay, 4 minus 2, 6 minus 4, 8 minus 6. Those are all 2. So this is arithmetic. Your common difference, 2. CD's common difference is fine. It's just D in your formulas, but common difference is 2. Now B definitely looks like it has a pattern. We're just not sure if it's arithmetic or not. So we can check. Okay, if you want to check, you can just say, okay, 1/4 minus 1/2, and then we're going to look at 1/8 minus 1/4. And these are fractions, so a little bit uglier to you. But we're just going to get a common denominator. So this is times 2 times 2 for making it 2/4. 1/4 minus 2/4 is -1/4. Okay, so that's what the first gap was. It went down by a 1/4. The second one, times by 2 again, because that gives us an 1/8 on the bottom. 1/8 minus 2/8, I get -1/8. Those are different. So that is not arithmetic. The common difference was not common. Okay, so this is geometric. It's actually geometric by what? Can anybody see it? 2, yes, but where's the 2 at? On the denominator. So it's really 1/2. But it is, you're right, in the sense it's doubling the bottom, but that's 1/2. It was geometric. Okay, good. Okay, so then we have -10, -4, 2, and 8. Okay, so we got -4 minus a -10, so that means plus 10. That's 6. I have 2 minus a -4. That's 6. And then 8 minus 2 is 6 as well. This is arithmetic with a common difference of 6. Okay, so we're all good there. Okay, especially you guys are my second time teaching this for the day, so definitely if I'm going too fast or you guys need any clarifications, please let me know. Okay, and I know that last period you guys are exhausted too, so just let me know. Okay, so right there, 4, 8, 16, 32, you can kind of see it's definitely doubling each time. So that's a geometric. So this is not going to be arithmetic, so we don't have to worry about a common difference there. Okay, so things you want to know for today is on arithmetic, your first term we refer to as A, and the common difference we refer to as D in the formulas. Okay, T1 is also first term, so T1 and A are essentially the same thing. Half those formulas are just putting T1 or A in there. I don't know why they feel important to have both, but they do. Okay, and so we'll talk about that here in a second. Okay, we're going to develop the general formula here in a second, and then we'll be doing some examples to finish. Okay, so say the values of A and D in the following sequences. Okay, so A here. Yep. Okay, D. 10. Good. Then A here. 15. Negative 5. Okay, good. All right, now let's go through a little investigation here about building the general term. I do ask for a general term today on your task check that's on Shobi. Okay, so you want to know what this means here. All right, so fill out this investigation. So for the investigation, you have the pattern of 2, 12, 22, 32, 42. So your T1 is 2, 12, 22, 32, 42. Your A is 2. Your common difference is 10. Just kind of filling out those term subscripts. Remember T1, term 1, T2, term 2. So you're going to notice a pattern here. So T1 is 2. T2 is 2 plus 1 times 10. T3 is 2 plus 2 times 10. So you kind of see it's lagging 1 behind. That's a 2 from a 3. That's a 1 from a 2. That's a 0 from a 1. So then we continue this pattern. It's 2 plus 3 here then. And then it's 2 plus 4 here. And it's 2 plus, if it's 30, it's going to be 1 back, 29 here. And so you get 32, 42, in this case, 292. Okay, so T sub n would then just be 2 plus n minus 1 times, 10 out of D. We know that's 10. I'll show you where the n minus 1 comes from. Just one second. So n is a number here, and the number we multiply to the 10 was always 1 less. So 30 minus 1 is 29. Correct. That's why we call it general. That's when we're stating in general terms. Correct. We don't know what n is in this case. So we look at the right side now, where we use all letters. Okay, so we do know most of the stuff. So we have a plus 1d, a plus 2d. So again, it's lagging behind by 1. So it's a plus 3d, a plus 4d, a plus 29d. And so if we wrote it in general terms, it would be a plus n minus 1d. And this is general. That's your full general form. It's right below there. We just developed that. So a lot of the work with this section, guys, is like you may be given 2 or 3 pieces of information. You have to find the fourth. Okay, you may know n and a, what's d? Or you may know d and a, what's n? Okay, working around those strategies through your algebra is what you're going to be working on mostly. Okay. All right, so kind of again, these formulas you don't have to memorize. These are in your formula sheet. Okay, this is the same formula repeated. They swapped out a and T1. Again, I don't know why they have to do that, but I usually just go with a usually. So, all right, so let's look at these couple examples here. So consider the sequence -6, -1, 4, 9. Determine the formula of the general term of the sequence. So this means, okay, kind of what Caden said, this is the general term in the terms of we can use it to find any term value. So what you're missing is n. We don't know what n is, because I can say, what is the 50th term? You plug 50 in for n. So when you have a general term, it allows you to find any spot of the pattern. Okay? So if we'll write it like T sub n, a plus n minus 1 times d. Now, looking at that sequence, what values do we know? Right, we know these. So what's my a? -6. What's my d here? 5. And so now we're just going to simplify this. Okay? We're just going to simplify it. So we're going to distribute. that, see? Negative 6 and negative 5 is negative 11. There's your general term. Okay? So again, if I told you what is a 20th term of that sequence, you'd put 20 in for n and you could calculate it. Okay? All I did here, if you're confused, I did negative 6 and negative 5. People are confused this morning. Negative 11. Just combine like terms. Now what's cool about this, you think about it, we talked about arithmetic sequences are in the form of linear equations. See 5n minus 11, that's a linear equation. The growth is by 5, right? Okay, so it kind of gives you that an illustration of the line there too. Okay, and so then like I told you, what's the value of the 12th term? We just put 12 right here. So go t of 12 equals 5 times 12 minus 11. 5 times 12 is 60, minus 11 is 49. T of 12 is 49. Okay, I want you to read example 5 and just kind of see if you kind of spark your brain about how you'd approach this. Because what they've done is they've shown you the pattern, they've shown you A, but they're not telling you what spot in the, like what n is for negative 117. How could you use the general term to help you here? So let me write it out for you. Let's just do this. Can you tell me what D, N, A, and T sub n, which things do we know? We know A and D, okay. So A is 3. All right, and then we know what's D? Negative 4. Yeah, actually got a negative 1 there. Went 3 to negative 1. So yeah. So it'd be negative 1 minus 3, right? Yeah, because they're coming down by 4 every time. Okay. Any questions? Okay, so now, where can we put the negative 117 somewhere? The Tn is, right? Because that's the confusing part. The T sub n is the output. We don't know what n is, but we know what the output is. So we put it over there on the T sub n part. Okay, and so see now we're solving for n. That's the algebra part I'm talking about. So this is the weird thing, is what I'm trying to tell you, is that we don't know what term number negative 117 is, but we know that n outputs negative 117, so we can put the negative 117 here. And so now we just go ahead and solve. Like that. I just distribute the negative 4 there. So negative 4 times n is negative 4n. Negative 4 times negative 1 is positive 4. Like that. And we're just solving for n right now. Should get 31. So that means that negative 117 is the 31st term. Okay, negative 117 is the 31st term. Okay. That's a good illustration, guys, of using your algebra, or like plugging what you have, what you know, to figure out the rest. Okay, so arithmetic means is going to be helpful because with it being linear, we can use some strategies with arithmetic means to help us solve. The terms placed between two values we're talking about is referred to as arithmetic means. So we'll just kind of get straight to the question here. It says place 3 arithmetic means between negative 4 and 8. So what it means is this is the arithmetic sequence. That's why it's arithmetic means. We have 3 gaps and we have an 8. Okay? And so they want us to figure out the 3 things is between. So what we're going to do is we're going to treat this as T1 for right now, 2, 3, 4, and this is T5. Okay? And we're going to solve for D, because D is what we don't know. We don't know how it's growing. Okay? So we're going to go A is negative 4. We know that T5 is 8. That's all the information I actually need, because if you go into your formula, we're going to do it for T of 5. So we're going to call our N5. We know that 8 equals negative 4 plus 5 minus 1 times D. see how I can use that term 5 to get rid of 2 unknowns? That term 5 I plug in, the d is the only thing I don't know now. So see, I put this for n, I put this for t of 5. That helped me kind of isolate things in a way I could solve for d. Because the 8 is 5 away from here. 1, 2, so 1, 2, 3, 4, 5. So this is my 5th term. Right, t5. Okay, and so now we're going to solve for n, or for d, excuse me. So 5 minus 1 is 4, so we get 8 equals negative 4 plus 4d. We add 4, divide 4, d is 3. Since d is 3, we can fill in these gaps now. Negative 4 plus 3, negative 1. Negative 1 plus 3, 2, 5, 8. You filled in the middle there, the arithmetic means. Okay. So we're just going to expand upon that, talk about different things you can do. There's a couple of slope things you can do. Okay, keep going from there. All right, now, of course, they throw variables at you, so you're starting to feel comfortable. They make your pattern have variables in it. Don't freak out about this, because what they tell you is they said that this is an arithmetic sequence. So this is what I want you to use the knowledge of. If it's a arithmetic sequence, you know that t2 minus t1 has to equal t3 minus t2. Because if it's arithmetic, that means they have a common difference. I know it looks weird because I'm not talking about numbers right now, but you know that t2 minus t1 equals t3 minus t2 if it tells you it's arithmetic, which it does. And so now we're going to use that to our advantage to help us solve with algebra. So we're going to go t2, so that's this guy, that's t2. So that's 3x minus 1 minus t1, x plus 2. Put your brackets there so you make sure you distribute the minus, equals t3 is 2x plus 1 minus 3x minus 1. Okay, just kind of pause for a second. I know it's a little bit harder to see, a lot going on. I'm using that I know the arithmetic sequence has a common difference to make these have an equivalent equation. Okay, while you're writing that down, we'll simplify here. So 3x minus 1x is 2x. Negative 1 minus 2 is negative 3. 2x minus 3x is negative x. 1 minus a negative 1 is 2. So I'm like that. That's where I'm at now. Now I'm just solving for x. There's a little bit of Math 9 stuff we're doing today, actually. Add x. So we get 3x equals 5. So in order for that to be an arithmetic sequence, x has to be 5/3. That's what we just figured out. In order for that to be an arithmetic sequence, x has to be 5/3. Okay, questions on anything I did there? Yeah. Yeah, so what I did was I kind of did 2 steps at once here, sorry, but I added the negative x over. So 2 plus 1 is 3x. I added the 3 over. 2 plus 3 is 5. Right, just moving my equation to get the x by itself. Yeah. Okay, so determine the numerical value of the 3 terms. So that means we want to go ahead and plug in 5/3 to these and get the numerical value. So we're going to go 5/3 plus 2, 3 times 5/3 minus 1, and we're going to do 2 times 5/3 plus 1. And so we're just going to look at these values, okay? So we're going to write them in fraction form. I'm going to show you kind of how you can see the arithmetic after it's simplified. So 2, so I can do 5/3, I can get these to be one thing. 2 is 6/3 if you do common denominator. Okay, so my first thing, 5 plus 6 is 11/3 is my first value. Okay, I'll get it. Okay, so then on the second one, we have 3 times the 5/3 there. There's a 5. It looks like a 3 on top here. This is a 5, sorry. Okay, so these 3's cancel. 5 minus 1 is 4. And I'll talk about what's different about this one. And this one, 2 times 5 is 10/3. plus 1, I'm going to make that 3 over 3. I'm sorry, that's just fraction work. I know I can do it a little quicker than you probably, but 10 thirds plus 3 thirds is 13 thirds. And what I want to show you is 4 is the same thing as 12 thirds. So look, 11 thirds, 12 thirds, 13 thirds. It's going up by a third every time. That's the actual arithmetic sequence. Okay, a lot of fractions there, a little bit ugly there, but any questions though? Okay. All right, we'll do a couple more things with arithmetic means here, and then we'll be finished up here. All right. Okay, so now they moved the arithmetic means to the third and eighth terms. So the third is 12. So 4, 5, 6, 7, 8, negative 18. So here's my T3 and my T8. Okay? So the one thing that we can do here is we're going to show you a couple different ways to approach this. You can approach it in a slope formula way, which we'll do here in a second, but I'll just kind of show you if you don't remember your slope formulas. That's what your slope is. That's kind of what part C is asking you to do. This way, you can actually cut this off. Because what are we missing? Are we missing, when you have gaps in the middle, what's the important piece that you're missing? The middle, and yes, and how do we get the middle? Right, and my point was is it doesn't really matter what the A is, because if I change my A, will my D still hit that if I go add or subtract from that spot? Yes, so what I'm telling you is we're going to kind of cut this off, pretend that this is T1 for a second. So this T1, we're now making this T6. So we got 1, 2, 3, 4, 5, 6. This is just so we can find D, guys, because if you have D, you can go both directions and figure it out from there. So finding the common difference is the important piece. Okay? So why I'm doing that is because then if I say, okay, T of 6 in this case is negative 18. T of 1 in this case is 12. So that means I'm going to say negative 18 equals 12 plus 6 minus 1 times D. See how I use that to my advantage? The only thing I don't have now is D. So I just cut this down. I said I'm going to pretend this is my T1 for a second. Okay, I'm going to solve for D. You can do that because it's a consistent pattern. It's not going to affect anything in terms of your outcome. So we can go minus the 12, negative 30, 6 minus 1, 5D, divide by 5, negative 6. So it's going down by negative 6 each time. So 6, 0, negative 6, negative 12. If we go the other way, 18, 24 is my real A. So state the first term and the common difference. So we just got the first term. So A, the actual first term is 24. Okay, so we can kind of erase this part that we cut things down to our advantage. The common difference is negative 6. Okay, I'm going to do it the kind of the slope way. Okay, the slope way. So T of 8, what is T of 8 in our problem? Negative 18. Okay, good, yeah. And then what is T of 3? 12. So minus 12. And you have 8 minus 3. So look what happens. Negative 8 minus 12, that's your negative 30 over 5. You get negative 6. Much quicker. Okay, it's much quicker, and you can do that with arithmetic because you can do slope form.
Where do they get the 8 over 3 for 8?
The 8 negative 3 is the term number because it's term 8 and term 3. Yeah.
So that's the,
That's exactly. That's like the X. Yep. Okay. All right, now I'm going to do a couple little things here, just kind of show you where this comes from in terms of variables. This part's just more for understanding. But they say, so we know that T of 3 is A plus 2D from our previous work on the previous page. We know T of 8 is A plus 7D. So if we do the same thing we just did, this form, A plus 7D minus A plus 2D all over 8 minus 3. They're just showing you why this works, okay, why the slope formula works. What happens to the A's? A minus A. Gone, right? 7 minus 2. I get 5D over 5. D. So just you can kind of see that That's how you get the common difference. Okay, that's just the algebra way of showing you the work. If you just understand the numbers, that's fine. Okay. And simply, this is just, in general, your common difference would be T of P minus T of Q over P minus Q, just like as a formula, if you want to use that. So if you have the term number in the output for two spots, you can subtract the outputs over these spots, and you'll get the actual difference. All right, we are on our last little example here. Okay, same type of idea. So this one, I really don't have to go over this because we've already shown you two different types of solving. But the only reason I'm going to go over this is because I want you guys to remember system of equations from Math 10. That's the elimination substitution strategies. Because those do come up in 30 and 20 kind of throughout. Every now they throw systems at you and you haven't seen in a while. Okay, so the only reason we're going over this is so you remember how to do systems. Okay, so what I'm going to show you is if we know that T of 3, okay, T of 3 is, or sorry, I'm going to go T of 8 first. Doesn't matter which one I go first, just in my notes, that's what I have. Is A plus 7D, right? We just talked about that. 7, it's a 7, yep. Okay, this is an arrow, a really bad one. Okay, at A plus 7D, and we know the output for that is negative 18 for T8. T3 is A plus 2D, and we know that the output's 12. So these are your two equations. What makes it a system is that we have what? What makes it a system? Why do we call it a system of equations here? You guys remember? It's because it has two variables. We have two unknowns. That's where you kind of get stuck with x and y when you're in Math 10. And so what we're going to do here is, this is a great elimination setup because why? The a's, yeah, the a's go away. I'm going to subtract these equations. That's your elimination step. Okay? And so see these go. See you later. 7 minus 2 is 5D. Negative 18 minus 12 is negative 30. Yep. And then we get that same answer, right, that we expected. We got negative 6 again. Just that same way we did it, the same answer we got previously, a different way. Remember, to find A, you just plug it back into either and you get A. So we'll put in the second one. A plus 2 times negative 6 equals 12. A minus 12 is 12. A is 24 when you add the 12 over. And so then there's your A, there's your D. We have one last thing to do there at the very end. It asks us to do one other thing. It wants us to find the fifth term of the sequence. So we're going to do that now that we have A and D. So I'll just kind of do it in this space right here. So T5 is going to be 24 plus 5 minus 1 times negative 6. You would see from our previous work, we know what it's going to be. It's going to be 0 because you get 24 plus a negative 24. T5 is 0. Okay. All right. So we'll